Hello everyone. Today we are going to discuss reaction curves and we will solve a numerical on reaction curves in a duopolistic oligopoly market, and we will see that how in a Cournot's model, in a Cournot's duopoly model, equilibrium can be established. Equilibrium is established graphically as well as mathematically using reaction curves. So we will understand it with the help of an example. Let us say there is a market demand and cost functions of a duopolist which are given by price is equal to 100 minus 0.5 x1 plus x2. C1 is 5x1, C2 is 0.5 x2 square. Here this is the market demand of the duopolist. P and x1 and x2 are quantity demanded by firm 1 and firm 2, the two firms in the duopoly model. C1 is the cost of the firm 1 and x1 is the quantity demanded. C2 is the cost of firm 2 and x2 is the quantity demanded. Now, since in duopoly, like we have studied in the previous videos, that in a Cournot's duopoly model, each firm is trying to individually, means firm 1 will try to maximize its profit, pi 1 and pi 2, firm 2 will try to maximize its own profit. So we will know that how to calculate the profit and then we will maximize it. So for firm 1, it will be total revenue minus total cost, and it will come up to be equal to 100 minus 0.5 x1 plus x2 into x1 minus 5 x1. That will be the profit of firm 1, which can also be written as 100 times x1 minus 0.5 x1 square minus 0.5 x1 into x2 minus 5x1. Likewise, we will do the same thing for pi 2 also, means the firm 2 also, px2 minus c2, and when we will calculate it, it will come out to be 100x2 minus 0.5 x2 square minus 0.5 x1 into x2 minus 0.5 x2 square. Now, if we will collect the terms, we will see that pi 1 is equal to 95 times x1 minus 0.5 x1 square minus 0.5 x1 into x2, and pi 2 will be 100 times x2 minus x2 square minus 0.5 x1 into x2. Now what will we do? We will do profit maximization. Right? So we will apply the maxima minima conditions here, and the condition is that partial differentiation of pi 1 with respect to x1 should be equal to 0, which is 95. We will differentiate this function partially with respect to x1 and it will come out to be equal to 0.5 x2. Likewise, we will maximize the profit for firm 2 also. Why are we doing it? Because in a Cournot's duopoly model, both firms are individually maximizing their profits. And this will come equal to 100 minus 2x2 minus 0.5 x1. So, these are nothing but the reaction functions of the duopolist. That is, x1 is equal to 95 minus 0.5 x2 and x2 is equal to 15 minus 0.25 x1. Can you see why are they called reaction functions? Because x1, output of x1 is basically depending on output of x2, and output of x2 is depending on output of x1. So these are reaction functions. If you will plot it graphically, you will get a graph like this. This is A's reaction function. The equation that we just did, you simply have to plot it. And this is B's reaction function. B's reaction function. And the point where they are meeting, E, is the Cournot's Nash equilibrium. So this is 100, this is 50, this is 30. We have taken x2 here and x1 here. This is origin. This is 80. And if we will solve these two equations, the reaction functions, x1 is equal to 95 minus 0.5 x2 and x2 is equal to 50 minus 0.25 x1. If we will solve them simultaneously, you will get the answer x1 is equal to 80 and x2 is equal to 30. Means firm 1 is producing how much? 80 units, and firm 2 is producing how much? 30 units when they are achieving the equilibrium. When they are achieving the equilibrium, and the total market output is 110. The total market output is 110 and market price is 45. The market price is 45. Now this is the equilibrium, okay, Cournot's model, equilibrium in Cournot's model. Here we have to understand that when these two reaction functions are meeting, that is becoming the point of Cournot's Nash equilibrium. That is becoming the point of Cournot's Nash equilibrium. Okay, so this basically implies that Cournot's equilibrium is getting determined by the intersection of the two reaction curves. It is basically the intersection of the two reaction curves. Okay, so the both the firms will react to each other in such a manner that this particular amount of combination of output for both the firms will be achieved. So that's it for today. Thank you. Just one important note here. We have done in Cournot's model, Cournot's duopoly model. In the previous video, we made an assumption. We made an assumption of zero costs, right? So this assumption is very unrealistic, and if we relax this assumption, Cournot's duopoly model can be better understood. It can be better understood using reaction curves. Using reaction curves. So this point you have to remember, and you do not have to get confused, because Cournot's duopoly model is based on the assumption of zero cost, whereas the reaction function approach that we are using, This relaxes the assumption. Everything else remains same in the model, but the assumption of zero cost or identical cost and identical demands is relaxed. And then in that case, this equilibrium is reached, which is known as Cournot's Nash equilibrium.